Hey guys, so I'm going to run through a few of the problems on the Unit 5 Quiz 1 review. This covers sections from 5.1 to 5.4. You will notice that there are way more problems in the 5.1 section because this is the most important section. If you do not know how to simplify radical expressions, then the rest of the sections are not going to go super well either because you end up using this in all the others. So basically, you are going to simplify, add, subtract, multiply, divide, and then use rational exponents. So do all four operations with radicals, including simplifying them, and then know how they are formed from exponents. So when you are looking at an example, remember that you want to find the biggest perfect square that you can divide this by if it is a square root. So I'm going to take my calculator and try dividing 147 by things that are perfect powers. Now, if you are taking this quiz in class, I will have it pulled up on the projector. If you are taking it anywhere other than the classroom, so 4th hour and 6th hour, then I will have you guys pull it up on your Chromebook. So 147 divided by, just going to take a random guess. 49 worked. Okay, this is what it'll look like if you didn't just randomly guess it first. I was completely guessing 147 divided by 64. So you don't want it to be a decimal, you want it to be a whole number, and you want this whole number to be something fairly low. So 49 times 3, and then you do the square root of the one that is a perfect square. So the square root of 49 is 7, and then you have the square root of 3 left over. And that's it. That's your answer. If there are exponents involved, so like this one down below, you want to deal with the 52 the same way that I did the 147. So since it's a square root, you need a perfect square that goes into it. I will also skip over to a cube root on this bottom row and tell you what to do if it is a cube root. So for this one, 52 divided by, let's start with 49. That didn't work, so I'm going to try 25. I skipped one. I forgot to try it. 36. Most of the time I go in order, but I forgot 36, so I had to go back to it. 16. 4. 4 and 13. Then the square root of 4 is 2. So 2 comes out front. I'm going to leave a little bit of gap. I'm going to write my 13 under the square root still. The reason why I left the gap is so that I can deal with my exponents. So for the exponents, remember that there is an imaginary index of 2 outside because this is a square root, and you need to figure out how many times this goes into the exponent. Because in order for a square root to cancel out, you need multiples of 2. So 2 goes into 6 3 times, and 2 goes into 4 twice. Neither of those have any leftovers, so that is your answer right there. And then I'm going to skip number 7 and move to number 8. If it is a cube root, then you need to find a perfect cube that goes into 135. So here are, actually, let's do this. Here are my perfect cubes. Oops. Eight, 27, and 64. So 135 divided by 8. Doesn't work. 135 divided by 27. Perfect. 27 times 5. And then the cube root of 27 is 3, because if you remember from my calculator, I had to do 3 to the third power to get it. And a cube root cancels out that third power. So that becomes 3 out front. And it multiplies by the number that's already out there, which is going to make -6 cube roots of 5. Okay, and then I'm going to just mention this Over here, you would be looking for something to the 4th power, that is 512. Okay, so that's the only difference between square root, cube root, and 4th root. A square root needs a power of 2 to cancel it out, a cube root needs a power of 3, and a 4th root needs a power of 4. That may or may not be a question on your quiz. And then we are going to work on adding and subtracting. What you have to do is simplify each radical expression, then combine common radicals. Common radicals means that it has the same index and radicand. Radicand is just a fancy way of saying the inside. So I'm going to do numbers 10 and 13. I want to split this up into the perfect square. Now, 27 is a little tricky because it is on your perfect cubes list, but you don't need a cube, you need a square. So I could do 9 times 3. The square root of 9 is 3, and I would be left with the square root of 3 afterwards. Then over here, 75 is 25 times 3. And the square root of 25 is 5. Now, when I bring that 5 out here, it's going to multiply by the 2. 5 times 2 is 10. Now, these both have the same index because they're both square roots, and they both have a 3. So what you're allowed to do is add the numbers out front. 3 plus 10 is 13. And then you leave the square root of 3 afterwards. You don't change the square root part. You can just add together the numbers out front, so long as they both have the square root of 3. The same thing can happen with cube roots, as long as they are both cube roots and they end up with the same number in here after they're simplified. So make sure you're reading the directions because it will help you simplify each radical expression first. So I need a perfect cube that goes into 250. I had already tried some of these up above, but I'm going to kind of remind you 2 cubed was 8, 3 cubed was 27. But this number is kind of high, so I'm going to keep trying a few more. So I'm going to start with these 3, 216, 125, and 64, because 250 is a pretty big number. Oops, if I can type correctly. So 216 doesn't work. But look at that, 125 does. And again, I will give you those perfect cubes so you don't have to test them out in your calculator. I just can't pull up that list at the same time right now. So then the cube root of 125, it was 5 cubed, so that's just 5. And then you keep the cube root of 2 afterwards. And what we're hoping is that this one ends up being a cube root of 2 as well. I can divide 54, or I can try dividing 54 by 40. Nope, actually by 27. There we go. Okay, it's 27 times 2. And the cube root of 27 is 3. I have to multiply that by the 4 that's already out here, and 3 times 4 is 12. And they do both have the cube root of 2. 5 plus 12 is 17. And there you go. Now, let's talk about multiplying. So there is one main rule with multiplying. You can multiply numbers out front together and numbers inside together, but you can't mix those two things together. It does say write your answer in simplest radical form. That means you have to simplify your answer at the very end. So I'm going to do this first one, and then I'll show you how to set up 18, but it's pretty much the same thing. So you have to distribute or FOIL, as you may have heard it. 4 times 2 is 8. 4 times negative square root of 3. You can put a negative 1 out there if you want. 4 times -1 is -4, and you leave the square root of 3. Because the 4 is outside, the 3 is inside, so you can't actually multiply those together. Then 2 times the square root of 3 is just simply 2 square roots of 3. And then this is the part where people get a little stuck. The square root of 3 times negative square root of 3. It's going to be negative, and you can multiply those 3's because they're both inside. But the square root of 9 is 3, so you just basically have that. Anytime you multiply a square root by itself, the square root's just going to go away. So you can write it either way. This way just saves you a step. And then you want to combine like terms if you can. That's what it means by simplest radical form. So you'll notice that these two don't have a square root with them. So you can do 8 minus 3. That's 5. And in the middle, these both have square roots of 3. So you can add their numbers out front, just like we did on number 10. -4 plus 2 is -2. Square roots of 3. And you're done. On number 18, be careful because you don't just square both of those. Instead, when you square something, you multiply it by itself. So you have to multiply this by itself. And then it works very similarly to number 17. Okay, flip into the back side now. This one starts very similarly on the back side. I'm not going to do this first one because it is pretty much the same, but I am going to do this one with you guys because you'll notice there's no like plus and minuses. It's just this times this. Whenever you see this, multiply the numbers out front together. So that's going to be 3 times -2, -6, square root. And inside, 12 times 2 is 24. X to the 5th times x squared means you add these two exponents. That's going to make x to the 7th. Y to the 7th times y to the 4th. 7 and 4 makes 11. And then we have to simplify this. So I need two numbers that multiply to 24, but I want one of them to be a perfect square. So that's going to be 4 times 6. 4 is a perfect square. And then the square root of 4 is 2, which is going to multiply by the -6 that's already out there. And -6 times 2 is -12. And now only the 6 is left underneath. Okay, I should have written that in the first place. Square root of 4 is 2, which gets multiplied by the -6 to make the -12. The 6 stays underneath. And then remember there's an imaginary 2 here. 2 goes into 7 3 times with 1 left over. So the x3 comes outside, the 1 that's left over stays inside. Then 2 goes into 11 5 times with 1 left over. Okay, and then I'm going to skip to 19. When it says rationalize the denominator, whatever the square root is on the bottom, you want to multiply by. If there was a number in front of this, you wouldn't worry about it. You just want to get rid of that. The reason why we multiply by the square root is because the square root of 3 times the square root of 3 is just 3 without a square root. Or you could say the square root of 9, which is, again, 3. On top, you can't multiply 12 in the square root of 3 because one's outside, one's inside. So you kind of just have to leave it like that. Before you box this as your final answer, though, double check. Can you divide the numbers out front by each other now? You can. 12 divided by 3 is 4. And then we're going to do the same thing. We would do the same thing on 20. 21 and 22 both have plus signs down here. If that happens, you have to multiply by the opposite of the whole thing, or the conjugate is what we call this, which is the same thing, but you put a minus instead of a plus. On the top, 5 times 4 is 20. And then 5 times negative square root of 6 is negative 5 square root of 6. I'm going to pause here to say something that you are not allowed to do. Make this 15. You can't make this 15 because this doesn't have a square root of 6 with it. But some of our brains want to do that. Resist that urge. These are just two separate things. And then on the bottom, 4 times 4 is 16. And then I'm going to take a second to write something on a sticky note because this happens every time you do this. When you multiply two conjugates, you're going to get negative 4 square roots of 6 and positive 4 square roots of 6. Every time, those are going to cancel out. And then all you have left is square root of 6 times negative square root of 6, which is negative because it's a positive times a negative. And when you multiply a square root by itself, it cancels out the square root. And then I'm going to cross that out on the bottom. 16 minus 6 is actually 10. So then just like over here when I checked the numbers out front, I need all three of these to have a number that goes into them, which 5 can be divided by all of them. So 20 divided by 5 is 4. Negative 5 divided by 5 is negative 1. And 10 divided by 5 is 2. Like that. I forgot to box my answer over here. All right, let's move on to rational exponents. So I'm just going to pick, let's see, these two. These are pretty simple. Whatever number is on the bottom of the fraction, a fraction exponent means a radical. Whatever number is on the bottom is the index. And whatever number is on the top just kind of stays with it. You can either put that 3 outside or inside. And then what we're going to do is the square root of 64, which is 8 cubed. And 8 cubed is 512. So what I would recommend is do the root first, that's 8, then do the power of 3. 8 to the third is 512. On 27, start with the radical. Whatever number is on the bottom becomes the index, and whatever number is on the top stays with that number. And then I'm going to do the 7th root of 128. One of the powers that will be on that list that I'm kind of giving you guys is the fact that 2 to the 7th is 128. But if you weren't sure, you could just check because you know you need a 7th power. So you could try 2 to the 7th, and if that didn't work, you could try 3 to the 7th until you found the right number to the 7th power that equals 128. So this ends up being 2 to the power of 4. 2 to the power of 4 is 16. All of these ones up here should have a whole number answer. And now let's talk about some of the ones on the bottom. Okay, so I'm actually going to do these 3. I feel like this part is a little trickier, so I'm going to go ahead and do a few extras. This 1/2 power takes the square root of that number. And the square root of 36 is 6. With the exponents, it multiplies. 1/2 times 4 is 2. 1/2 times 12 is 6. And you're done. Just remember that with the regular roots, this isn't half of 36, it's the square root of 36. And then if it's dividing, like 32, 50 divided by 10 is 5. And then you're going to subtract those exponents. 4/5 minus 1/2. Okay, and then I'm going to change these both to tenths. I'm going to multiply this one by 2. That makes 8/10. And I'm going to multiply these by 5, which makes 5/10. 8/10 minus 5/10 is 3/10. And then I would do 1/3 minus 2. This one's a little bit easier because 2 is the same thing as 6/3. And 1 minus 6 is -5/3. And then if you have a negative exponent like that, you're going to want to put it on the bottom. So I'm going to put it down here, but I'm going to go ahead and make it the cube root of y to the 5th. And I'm going to make the top one the 10th root of x to the 3rd. Whatever number was on the bottom goes out front. Whatever number was on the top stays with it. The only reason why I didn't have to write the negative on that 5 is because I already moved it to the bottom. So anytime you get a negative exponent, it goes down to the bottom of the fraction. And then I will do number 33 as well. This 1/2, I'm going to get rid of the parentheses first. It's always a good idea if you're stuck. This 1/2 takes the square root of 9, which is 3. And then it takes half of each of those exponents. So instead of 4 and 8, now they're going to be 2 and 4. Half of 4 is 2, half of 8 is 4. And then this 1/3 power does the cube root. The cube root of 8 is 2. We're going to be multiplying these answers at the end. And then 12 times 1/3 is 4. 6 times 1/3 is 2. And then we're going to multiply the regular numbers. That makes 6. And add the exponents on the same letter. So 2 plus 4 is 6. 4 plus 2 is also 6. Let me know if you would like to see a video of more of these examples, but that is most of what is on your test.